Okay, this is for algebra. It is the graphic organizer for the entire Chapter 9, which was polynomials and factoring. We began the chapter with looking at some basic operations with polynomials, right? So we started with addition, subtraction, and then multiplication of polynomials. So underneath that first panel, the first thing we might think about is that when we add or subtract polynomials, we have a choice of aligning them vertically, aligning like terms, or leaving them horizontal, right? And in that case, I use a checkoff system to make sure we have accounted for everything. So in this example, go ahead and take the second term, the binomial, and line it up underneath the first term. So I'm going to try to grab a pen and do that. And so I have how many a to the thirds right here? 1, right? So I'm going to add it under here, 1a to the third. And I'm going to bring this term over here, -1, underneath its like term here. So you could align all of these things. And this is much harder to work with than the smartboard. So there we go. And now we just combine the like terms. How many a to the thirds? We have 8, right? It's a to the thirds, and we have 8 because we're adding them. There was nothing to add to our a squareds, so we have -4a squared. That's a 2. And we have nothing to add to the the first degree term, so we just have -2a still. But notice that we have a +1 and a -1, which are opposites, so we're left with nothing. I don't even need to write anything here. So there we have our term added up. Okay, let's try this one horizontally. And so the first thing we do is we change subtraction of this whole term to addition of each of the opposites, right? So we basically are distributing -1 times each term, right? So we could say I'm adding a negative here, a positive here, and a positive here, right? Okay, so once we have the terms with their correct signs, we can start to combine like terms. So we could start with what's the highest agreed term? Greatest exponent is here, and there are no others. So we begin with -2, k to the fourth, right? And then we move to, are there any third degree exponents? And here's one. So any to combine? No. So we just have +3k to the third. And now we look for second degree. Here we have -1k squared, right? Or -k squared. And now we have any first degree. Here we have just a 7k, right? So +7k. Combining all like terms, right? And then I have +5 and we have a +6. Those can be combined and give us +11. So there is the horizontal method, checking each term off, making sure you've accounted for every term, right? Okay, multiplication, we have the option of multiplying vertically. And so this was way back at the beginning of the chapter, but we said if we align the two big factors, polynomial factors, in columns, we can just multiply the entire polynomial on top to one of the terms, and then the entire polynomial to the other term. So we could say 4 times 2 is 8, and 5y times 2 is 10y, right? And the 8 is positive, so let's put a plus sign here. 10y is also positive, so we now have y squared times 2, and that leaves us with 2y squared, right? So, good. Now we move to the second term here in the binomial. 4 times 3y is 12y, and let's put that underneath its like term, 12y. Right? 5y times 3y, 15y squared, 2y factors, right? 15y squared. Okay, and that was a +12y, so notice we have to put those signs in now. And then we have y squared times 3y, so this is positive, which is 3y cubed. And cubed. Okay, and now we can just add these terms, and we have 8 plus how many y's? 22, right? 22 y's. So much easier on the smartboard. And how many y squareds? Looks like 17. And then how many y to the thirds? 3. 3y cubes. Right? That's a 3. And there we have our product after multiplying a trinomial by a binomial. And we spent more time during this chapter multiplying two binomial factors, right? So on your last panel, let's do that. And we used this acronym FOIL. So we multiply the first terms, 3x times x, the outside terms, O, the inside terms, which combines usually with the O, and the last terms. And so I'm going to try typing it this time. So we end up with 3x times x, or 3x squared, right? And then we have outside 3x times 4, so that's 12x. And then inside we have negative 2 times x, negative 2x. So 12x minus 2x is 10x, positive 10x. And then when we look at the last terms, let me move that down here, negative 2 times 4, so we end up with minus 8, right? So there is the trinomial we get when we FOIL this pair of binomials. Okay, so the second big section we started to talk about after doing these basic operations was special products. We have some special products. And the first special products is a square of a binomial, this product. And so see if you can finish the rule. What do you get when you square a plus b? And hopefully, pause it, come back. You have said you get a squared plus 2ab plus b squared. You get not just a squared and a b squared, as some might think, but you end up with a middle term as well, right? And if this operation is subtraction, we end up with negative 2ab in the middle of this perfect square trinomial. So when you square a binomial, you get a perfect square trinomial, which means the first and last terms are perfect squares. And in between, you have 2ab. Oops. So let's try this. Can you give me the square of this binomial? Pause the video, come on back. And hopefully you got it. Hopefully you didn't need to do this, but you could do this, right? You could do this in FOIL. Or you could say, what's the first term squared? And it is 4x squared. And the last term square would be on the end, right? But in between, we would have 2x times negative y, negative 2xy, twice, which is negative 4xy, right? And then, of course, on the end, we have our last term squared. So there we have a perfect square trinomial. The second pattern we learned was the sum and difference pattern, my favorite of the two. And the sum and difference pattern says that when you have the sum and difference of the same factors, right, that you end up with a difference of two perfect squares. And that happens because the outside is a negative ab, but the inside is a positive ab, and so they're opposites, and you are left with no middle term. So see if you can answer this question. Oops, revealing too much. When you FOIL this, or when you see this, you know you're going to end up with the first term squared, right? Minus the last term squared, or 25. The difference of two perfect squares. Very good. Okay, our third section after special products was solving polynomial equations in factored form. Okay, so the first thing we did there was factor and used our zero product property, right? So let's try that here. If we receive an equation, so we have a basic equation already set equal to 0, we know that if we can find the factors of this polynomial, one of them would have to be 0, right? So the first step was to pull out any greatest common factor. So what factor can go into both of these terms? And I hope you're saying 4 and there's an x, right? So we could write 4x and then create a binomial that when we multiply 4x to, we would get back to this original expression here. So 4x would be multiplied to 2x, giving us 8x squared. and 4x would be multiplied to 1, right? Giving us minus 4x here. Okay, so as we look at this, we now can say, what would the values of x equal that could make this equation true? So x could equal, in this case, 4 times what is 0? 4 times 0, right? If we plug a 0 in, the entire equation will equal 0 because of this factor x here. Now this binomial factor, if I plug in 0 here, I would have 0 minus 1, which is negative 1, right? When I multiply that to this 0, it becomes 0. But what could I do to this binomial to make it equal to 0? Well, we could add 1 and divide by 2, right? Leaving us with 1/2. And so 1/2 is the second solution. 2 times 1/2 is 1, and 1 minus 1 makes this whole thing 0. Okay? So our solutions are 0 and 1/2. Okay, next step is to, let's see if I can get this to work, solve something a little different. How about solving an equation that's not equal to 0? So here we have an equation that's not equal to 0. Can you solve it? Well, we're going to set it equal to 0, right? So we're going to maybe move 7h to the left. We could move 21h squared to the right, but I like the fact that it's nice and positive, and it's the higher degree, right? So let's move 7h to the left by subtracting it from both sides. That would leave us with 21h squared minus 7h, right? And on the right, whoops, let me get out of this exponent mode, minus 7h. The right side now equals 0. Okay, so now we're back to where we were on the previous screen. We're going to factor the GCF out. So what number goes into both of these? 7, and they both have an h. Okay, 7h times what gives us 21h squared? 7h times 3h, right? Minus 7h times 1 gives us 7h, right? Equals 0. Okay, so now what factors, or what values could we plug in for h here in order to make this equation true? This one's easy. H could be 0, right? And in here, again, 3h minus 1 would have to equal 0, the whole thing. So we would add 1 and divide by 3, so 1/3. Good job. Okay, finally, we could say that in our last section we had to completely factor and solve trinomials, and even 4-term polynomials. So let's see what we did first. We looked at some actual examples before we looked at the rule, remember? And that's because the rule is really tricky. B, the middle term, is a combination of what you get when you multiply the outside inside, and you end up adding p plus q, right? C ends up being p times q, the last terms. So we looked at this rule after we actually tried factoring a trinomial. So look at that rule. Now let's factor this trinomial. This is not a perfect square, so we're just going to set it up with 2 sets of parentheses like we did in class. So I would have something here, and then I'm going to have parentheses, something here, making room, right? The first term in each of the binomials would have to be what in order to multiply them together, FOIL them, to get y squared? They would both be y, right? Okay. And then notice the last term is positive, but the middle term is negative. So when I multiply the last 2 terms, I'm going to get a positive, but the middle is negative. So this means that both of our operations in this binomial are negative, right? Oops, negative. Okay. And what factors of 21, since they're both negative, add up to 10? And I'm sure you got it. It's 7. Let me bring that parentheses in a little bit. And 3, right? Good. So you can always be sure that you did the right thing by FOILing. Y squared minus 3 minus 7 is minus 10, and 21. Okay, set this equation equal to 0 and factor it, and come back and see how it looks when it's factored. Okay, factored the GCF, binomials, and solve. Don't forget to review the thrown object model, factoring special patterns, right? A square, difference of two perfect squares is the sum and difference, and this would be the square of a binomial, and factoring for group terms.